Welcome to EPG Pathshala program in Linguistics. We are going to discuss a module from the course, An Introduction to Computational Linguistics and Speech Processing. The coordinator of this course are Professor Pramod Pandey from JNU and Professor Vidya-mitra Sarma from IIIT Hyderabad. The module title is Evaluation of TTS Voice, that is, Evaluation Procedure of Text-to-Speech Synthesis System Voice. The module is authored by Professor Hemant Patil from IIT Gandhinagar. I am Amardeep Kumar Singh and I am going to present this module on behalf of Professor Patil. Outline of the module named Evaluation of TTS Voice. In this module, we are going to discuss the different methods of evaluation of TTS voice. Firstly, we will be discussing the subjective evaluation and then objective evaluation. At the end of this module, we will be discussing an experimental results which is done on Gujarati language, which is one of the Indian languages. So in subjective evaluation, we will be discussing mean opinion score, degradation MOS, which is mean opinion score, semantically unpredictable sentences, preference test, issues and problems in subjective tests, and the Blizzard challenge. Then again, in objective evaluation, we will be discussing distance-based measure, likelihood measures, speed prosody-based measures, limitation and issues in objective measures. At the end of this module, we will be discussing the experimental results on the Gujarati language TTS voice and as well as on the Blizzard challenge database. At the end of the summary, we will be discussing throughout the process the TTS system, which is the text-to-speech synthesis system, in detail. Let's get into the whole discussion in detail. So, in this module, the evaluation of TTS voice, let me introduce first. So, since the use of text-to-speech technology is increasing, there is a high demand of a TTS system that can produce natural and intelligible voice in any environment. In order to improve a speech synthesis system, synthesized speech must be properly evaluated so that the gap between natural speech and synthetic speech can be identified and should be taken care by developing proper methods for different modeling block of TTS systems. TTS systems evaluation includes finding effectiveness of individual building blocks of TTS as well as if the final outcome, that is the synthetic speech. TTS evaluation can also be done for other system components such as text normalization. However, this is not within the scope of the present module. We will describe it sometime later. For evaluation of synthetic speech, two main aspects of TTS voice, namely naturalness and intelligibility, must be considered. In this module, we will address the subjective evaluation as well as the machine evaluation approach known as objective method for synthesized speech quality measurement of TTS voice. So, in the last module, we have adapted the HTS system on Gujarati language. Here, we will also show the evaluation of the Gujarati TTS voice using both subjective test and objective measure as discussed. So, let me first describe the subjective evaluation methods. So, subjective evaluation of TTS includes listening tests in which synthetic speech is played to each listener, from which he or she has to judge speech quality, naturalness and intelligibility of TTS synthetic speech. Typically, large number of subjects, at least 10 to 15, are required for subjective tests so that statistical analysis can be carried out to obtain meaningful scores for each test. In this, we will define different parameters and tests such as mean opinion score, degradation mean opinion score, semantically unpredictable sentences, and preference tests. So, while defining the mean opinion score, for evaluating naturalness of synthetic speech, This mean opinion score test is conducted in which subjects have to judge the synthetic speech quality and give a rating in the scale of 1 to 5 as suggested in ITUT by the researcher, where 1 corresponds to the worst quality and 5 corresponds to the excellent quality, as you can see in the table shown on your screen. So MOS test is conducted in which subjects have to judge the synthesized speech quality and give a rating in the scale of 1 to 5. Now, mean of all the opinions from all the subjects is considered as a score for particular stimuli of a given TTS system. It is sometimes advisable to present natural voice along with the synthetic voice generated so that listeners can judge the naturalness of the synthetic speech. One can also use other factors including naturalness as suggested, like pleasantness of voice, listening effort, articulation, pronunciation, speaking rate, acceptance, and finally overall impression. For subjective tests using MOS, we are expected to take subjects in young age group, that is from 20 to 30 years, in order to alleviate errors in listening tests due to phenomena of hearing loss for more prominent in older subjects. In a speech enhancement application, intelligibility is more critical than MOS test, as speech is natural unlike machine generated speech but may not be intelligible due to noise. For speech coding applications of MOS test is similar as TTS, as in HTS speech generation is carried out using a vocoder. Now let me explain the degradation MOS, that is the degradation mean opinion score. So TTS voice quality naturally depends on the quality of the recorded or natural voice, specifically in the case of USS system, that is the unit sound system method. The subjective score obtained for synthesized speech is normalized with that obtained for the natural speech used in TTS building. This subjective MOS is called as degradation MOS. This assessment method is similar as prescribed by ITUT recommendation P.800 standard. The listeners compare the synthetic speech quality to be assessed with reference natural speech to assess the degree of degradation in the speech samples. Hence, DMOS measures TTS voice quality relative to natural speech. In case of DMOS, synthesized and natural sentences are randomly played. The scale for scoring the quality of speech is same as for the MOS test. Now move on to the next slide. Semantically unpredictable sentences. It is a free answer test evaluating intelligibility of speech at word level as well as sentence level. Test sentences for the SUS test are prepared such that they are syntactically normal. However, semantically abnormal. This is done to decouple the semantic dependencies of one word with another word in order to contribute what is emphasized at word level. Example of this include, he is walking in notebook with blue shoes. Listeners have to write down what they heard in sentence. So using semantically unpredictable sentences allows evaluators of TTS voice to test the intelligibility of words without the context of the sentence, cueing listeners to expect a particular word. The general algorithm for generating these kind of sentences are given in the research paper, which discuss process of making test set for the SUS test. Now let me come to preference test. In these kind of tests, subjects have to do specific tasks assigned to them to evaluate TTS speech quality by asking questions such as, which system do you prefer? Checking speaker similarity of synthetic voice compared to natural. Examples of such tests include A/B tests, ABX tests. In A/B test, during the listening task, a pair of stimuli of two different systems, namely A and B, is presented, and subjects are asked to give preference to the system in terms of which sounds better, more natural or similar to natural voice used for building TTS system. In ABX test, one reference stimuli X corresponding to natural speech signal and a pair of stimuli A and B are presented, and subjects are asked to judge which of A or B is closest to X in terms of naturalness or intelligibility of synthetic speech. Now, talking about all the tests, let me also describe some of the issues that are present in subjective tests. The first one is that it takes a significant time and the cost is significant, which is required for conducting the listening tests. Secondly, these tests are not always reproducible because of the difficulty and also the cost involved in bringing the same subjects more than once. The state-of-the-art HTS offers flexibility of generating voices. Hence, each time one change something, one generate new voice. Every time calling subjects and conducting subjective test is really not advisable. Thirdly, large numbers of subjects are required for better evaluation in a statistically meaningful sense, which are difficult to obtain. It is due to the reason every year Blizzard Challenge is organized, which includes listeners more than 200 in number with different category. Fourthly, some authors describe some cognitive factors must be taken into consideration for subjective tests. These cognitive factors include whether the subjects are paying attention while conducting listening tests, dependency on subject's mood, environment of listening test, personal feelings, etc. Did the listeners really understand what is type of test, how the test is to be taken, etc. As sometimes they do not know what they are doing. Sometimes in a hurry, they does not listen whole sentence properly, and many other factors that affect scoring in listening tests. Also, dependency of listening scale with age of subject and hence possible hearing loss make scores obtained via listening tests error prone. And there may be many more problems in subjective tests as far as the cognitive factors are concerned. Now let me move on to the Blizzard Challenge that I have just mentioned. So there are several issues regarding the subjective test in TTS. However, it may be possible to overcome some of the limitations of the subjective tests if they are based on more rigorous tests with many subjects, like more than 100 listeners. In order to better understand and compare research techniques in building corpus-based speech synthesizers on the common speech data, the Blizzard Challenge has been organized every year as satellite event of the Inter-Speech Conference series. The challenge was conducted by Alan Black and Kiichi Tokuda as described in their Inter-Speech 2005 paper. And in 2007, they were joined by Simon King. The basic challenge is to take the released speech database common to all the participants, build a synthetic voice from the data, and synthesize a prescribed set of test sentences. The sentences from each synthesizer are then evaluated through listening tests, which include many subjects with different categories like speech experts, normal subjects with different age, visually challenged person, etc. In Blizzard Challenge 2014, for the first time, Gujarati speech database was made available by DAIICT TTS Phase 2 Consortium partner. One of the project staff members built a baseline system for Blizzard Challenge 2014. Now we'll talk about some other kind of evaluation methods, that is the machine evaluation method, which is also known as objective evaluation. So to overcome the issues described above in the subjective evaluation methods, An instrumental quality prediction, also known as objective measure, is of high demand in TTS research community. Objective measures offer a clear measurement of voice performance by applying relevant speech signal processing algorithms. The literature meaning of word objective is not influenced by personal feelings or opinions, rather considering only facts. Objective evaluations give consistent evaluation, unlike individual personal opinion, which is governed by personal feelings, moods, etc. It also does not require large time and cost for evaluation. However, till date, there is no universally accepted objective measure for evaluation of TTS quality and intelligibility. Here we will describe different measures for the objective evaluation. The first one is distance-based measure, then the likelihood measures, and the third one is speech prosody-based measures. First, let me describe the distance-based measure. So, in this case, male sepstral distortion, that is MCD, is generally used for measuring the speech quality, namely naturalness and intelligibility, comparing synthetic speech reference natural speech signal. To measure the accuracy of the spectral envelope of the synthetic speech, we use average male sepstral distance, which is only calculated during periods of speech activity. Objective evaluation is carried out by first aligning reference and test utterances. As both may have different durations, there are two ways to approach for MCD measure. First, we can use HTS to synthesize the speech which is of same duration as that of the natural speech, or one can use warping techniques, block diagram of which is you can see on your screen. So the first one, the MCDK, is given by this particular formula, and then the MCDK is governed by distance calculated from DTW of x and y divided by length of the reference sequence. And this is known as the dynamic time warping, which is used to align speech features on frame level. Now below you can see this a block diagram where you can see the natural speech goes into pre-processing, then the features are extracted, and finally it goes into the DTW alignment. And in other words, parallelly, synthetic speech also goes into pre-processing, then the features are extracted, and then finally it goes into DTW alignment. The main problem of distance measures is time alignment of both speech signals, natural and synthetic, since natural and synthetic speech have different time durations. Even if we solve these issues with DTW, there are more limitations of such objective measures. There are many possible realizations of natural speech of same utterance possible. So by taking one realization, it is not a proper justification for calculating MCD measure. Another limitation is that the perceptual distance that we perceived as listeners between synthetic speech and natural speech is not same as calculated by distance-based objective measures. So we could see that there are some issues with this measure as well. So moving on to the next kind of measure, which is likelihood measures. So we know that MCD require natural speech of same utterance as synthetic speech. This may not always be possible. To that effect, some researchers proposed likelihood-based measure, which includes hidden marker model as a reference of natural speech, which is different than the one used in building TTS system. It is provided that this measure did not work well and is of very limited use, like measure quality of a TTS system against HMM models of natural speech signal. Now I will define another kind of measure, which is a speech prosody based measure. So prosody is the most difficult feature to include in TTS system. Prosody features include fundamental frequency, which is defined by FO, and its statistics, duration features, etc. Quality of fundamental frequency generated by HTS system is measured by root mean square error of log FO. that is the logarithm of fundamental frequency of speech generated by STS system and natural speech signal. Now here I will review a few of the prosody features, which are statistics of fundamental frequency, that is F0, which includes mean, standard deviation and range. Now the second one is the voiced segment based features, which are described by F0 x of n. Now I will describe three properties which are used, the mathematical form of which are used in this kind of measure. The first one is the picked ratio, which is also described by PR. It is defined as the relative number of segments per signal whose magnitude of mx is above a threshold 4. And the formula for the PR is, as you can see on your screen, and where PR belongs to the interval 0 to 1. This indicates fraction of segments whose slope exhibiting a minimum slope threshold of same magnitude. Hence it counts how many segments have pitch changes with reference to threshold. PR equals to 1 means all segments have significant pitch changes with respect to threshold 4. Now the drop ratio, which is denoted by dr, so it is defined as the formula, as you can see on your screen. So it is proved by the researcher that relative number of declining F0 contribute positively to perceived naturalness. This is also related to drop of F0 contours in a segment naturally occurs at the end of sentence. Now I will define another ratio, which is known as the variability ratio. It gives the relative number of segments with mean derivative above 4. The formula of the VR is, you can see here, VR is again in the interval 0 to 1. The mean derivative of pitch per voiced segments give temporal variations in pitch over time. So after describing these kind of measures, I will describe some of the limitations and issues with the objective measures as well, as we have done already for the subjective measures. So now for objective measures there are also some sort of limitations and issues. So firstly, it is still not clear in the literature as to how to define naturalness of a speech signal. Hence one takes any features from synthetic speech and comparing them with natural speech signal. This may or may not give good correlation with subjective scores, so still proper features and methods need to be developed. Natural and synthesized speech has different acoustic properties and prosody. Any of these differences could contribute to naturalness and an intelligibility loss for synthesized speech. Objective measures designed until now are for natural speech and its noisy version. So we do not know whether they will affect the performance of objective measures, which are mainly designed to with regard to the perceptually salient properties of natural speech signal. Thus we can see that there is no measure reliable until now, and there is a need to have a measure that highly correlates with subjective as well as gives better ideas of naturalness and intelligibility of synthetic speech. So these are the limitations and issues with objective measures. Now let's move on to the experimental results on the Gujarati TTS Voice. So in the last module we have described the adaptation of a generalized STS framework on the Gujarati language. So here we will describe the experimental results which we have got on this language TTS Voice. So both subjective as well as objective measures have been defined. So we are now going to discuss those two kinds of measure for speech naturalness and speech intelligibility. We will also describe the Blizzard challenge database as well after this. So firstly, the objective measures are mostly independent of any particular language. So in case of Gujarati unit selection system, the system has been built for Gujarati USS, that is unit selection system, on female voice using training data from 1 hour to 8 hours in order to check improvement in unit selection system on hour basis. For testing speech quality of synthetic speech, we have used 9 utterances of synthetic speech which are not present in training data. Gujarati HTS system. The system has been built for Gujarati HTS on female voice using training data from 1 hour to 4 hours in order to check improvement in HTS on hour basis. For testing speech quality of synthetic speech, we have used 5 utterances of synthetic speech which are not present in training data. For both TTS systems, subjective MOS is taken from 11 subjects, namely 8 male and 3 female, in a silent laboratory environment with high quality headphones. So let me describe these subjective evaluation results. So on your screen you can see 2 tables. The first table describes subjective evaluation of USS Gujarati system, while the second table describes the MOS evaluation of HTS for Gujarati language. So the 2 methods are shown side by side here. Subjective listening tests have been conducted for unit selection TTS system for male voices for 7 hours of training data and female voices with 8 hours of training data. The evaluation has been done with help of 20 subjects who are native Gujarati speakers. The MOS, DMOS and WER evaluation of TTS system for Gujarati language can be seen from in table. The first table on your screen, we can see that male USS has higher MOS and DOMS than low WER compared to female USS system. As you can see, evaluation of STS system was done with 10 listeners and MOS score for male and female voices are shown in table 3. We can see that with only 4 hours of data, MOS of HTS system share comparable to USS system, which use almost the double amount of speech data used in USS building. Now I'll show the results on MCD tests. So you can see the first table on your screen is the MCD score for Gujarati USS system, while the second table is the MCD score for Gujarati HTS, which is the hidden Markov model text synthesis system. So we can see from this table that MCD measure is not able to give proper measure of naturalness for unit selection system, and hence no correlation at all is observed. On the other hand, for HTS, MCD measure give good correlation coefficient of -0.86. Hence, MCD measure is still now used as a reference-based objective measure for TTS speech quality. From the table on the right side, you can also see that MOS of HTS systems increase as we increase amount of training data in HTS, which is also reflected in MCD scores. Now let me show you the results on pitch related features. So it shows the results of correlation coefficient of prosody features based objective measures for HTS system. We can see that all features correlated well with subjective tests except feature PR and VR. Hence, overall correlation of 0.44 was obtained. In table, you can see clearly the correlation of feature with subjective MOS for STS-based Gujarati TTS. Now, let's move on to the experimental results on Blizzard challenge database. So, on your screen, you can see correlation coefficient of different features. As I have described earlier, the Blizzard challenge 2010 and 2011 database news sentences category are used in these experiments. Both databases have TTS systems including HMM based, unit selection TTS and hybrid TTS. We used different features in distance based objective measures. Features include magnitude based features, male frequency septal coefficient, MFCC, cochlear frequency substral coefficients CFCC, and phase-based features modified group delay substral coefficients, that is MGDCC. CFCC features are based on several approximate operations in auditory system, which is represented by auditory transform. Group delay features are one way of implicit representation of phase information of speech signal. In speech processing, the MOD-GDF feature are proposed, which shows that these features contains a spectral information, that is resonances of vocal tract system. MOD-GDF is used as features after applying log and DCT called MGDCC features. The results of these experiments you can see in this table, and now it will be easier for you to understand the table since I have defined all the parameters with their context. So the experimental results show that distance-based measures still do not work well with Blizzard challenge databases and need more general objective measures for measuring quality of TTS voice. We will conclude here. In this module, the evaluation methods for the TTS voice have been discussed. Firstly, we have described the subjective measures for the speech quality of TTS voice, such as the opinion score, preference test, and intelligibility tests. We have seen that the subjective measures have some limitations, and to overcome these limitations with a large listeners, a conference is organized known as the Blizzard Challenge, where a huge database for the listeners is organized. Now we have also seen that the subjective measures can be accompanied by a few objective measures. The objective measures include distance-based, likelihood-based, and the experimental results for a speech quality test is evaluated using both the subjective test and the objective measures. It has been concluded that the subjective test is a must for the evaluation of a TTS voice. It is also been seen that the subjective measures are not in correlation with the objective measures. Therefore, we are far away from concluding to a measure which can assess the naturalness and the intelligibility of the TTS voice. So, a research area is open for a new and enhanced method for the evaluation of the TTS voice is still open.